Number 13 has a cart with a given velocity, strikes. So strikes implies a collision. 10-pound cart initially at rest, and we even say collision there. And afterwards we know the velocity of the 8-pound cart, and we will know the coefficient of restitution. So this implies that it's not a perfectly inelastic or perfectly elastic collision. So we're going to somewhere use the equation of coefficient of restitution being the difference of the final velocities. Let's see, how do I want to label this? Final velocity of the 8-pound minus the final velocity of the 10-pound over, and that's negative, the final velocity of 8-pound minus the final velocity of the 10-pound. So I'm using subscripts to designate the weight of the cart to keep them straight. Okay, but we also need to use conservation of momentum. Momentum is conserved. We have, we'll assume no external forces in the direction that they're moving. Okay, and conservation momentum says the mass as the velocity of the 8-pound, velocity of the 10-pound is same before. That total is the same before and after. I'm using primes for the after. Alright, so there's our two equations. The values we don't know. I'll come back to that. Let's draw a picture here just to sort of show things here. We use positive to the right. Okay, so here's my 8-pound and here's my 10-pound. And we said it's moving at 6 feet per second, and its velocity equals 0. So this is before. And then afterwards, given some information, 8-pound cart is moving at 2 feet per second. Okay, so obviously the 10-pound cart is, unless they stick, well, is moving. We don't know that value, so there's one value we don't know. Okay, another value, since we have two equations, is this E value that we're going to find. Alright, so we'll use conservation of momentum to find this V10 prime. Oops, I forgot to write 2 feet per second. Let me rewrite that a little better. Alright, so that's V10. Alright, so just translating that down there. All these have mass in them, so I can use weight because I would just be dividing 32.2 by each value. So I'll be a little sloppy here and use weight for each one. So we'll have 8 times velocity of 8 before, which is a positive 6, plus 10 times 0 is equal to 8 times the velocity of 8 after is a positive 2, plus 10 times V10 prime. V10 prime will work out to be looks like 8 times 6 minus 8 times 2 divided by 10, or 3.2 feet per second. And that'll be to the right. Okay, and bring it back over here. So now we can calculate E. V8 prime was 2 minus 3.2 over V8 was 6 minus minus 0. I believe that's the right number. Okay. So 2 minus 3.2 is a minus 1.2. That minus will make it a positive 1.2 divided by 6, or 0.2. E is unitless. It's a ratio of differences in velocity, so no units on that guy.